So we're going to do 11.3 today. It's about inferences about two means. So we are still working with two populations, but now we are working on independent samples. If you remember in 11.2, we worked on the inferences for two means, but they were dependent samples. Okay, now we are going to work on independent samples. What happens then? So here are on the first page all the basic steps as we go. They are similar to all the testing going on. First, we check the requirements. Let's go over the requirements. The population standard deviation are unknown. So the population from which the data is taken, we do not know the standard deviation. Two samples are independent. So this one works when they are independent. The last method worked when they were dependent. Both the samples are simple random samples. Obviously, we want that. Both the samples come from a population that are normally distributed or the sample size are larger. So if the sample size, both the samples are large enough, we do not need to take the check of normality. Okay. But now, as they are not dependent, the sample size can be different. So first sample 1 size is N1 and sample 2 size is N2. Two different sizes because two different samples, right? And they are not dependent, they are not in matched pairs, so they don't have to be the same size sample, they can be different. Then we write the hypothesis. In this case, we write the hypothesis exactly how it is. So as we said earlier, so we have hypothesis can be written as your null hypothesis is always the population mean of the first one is equal to the second one. H1 is either mu1 is not equal to mu2 or mu1 is more than mu2 or mu1 is less than mu2. So in when it is independent sample, we cannot talk about mu d. So you need to remember that clue. Okay. So when you're talking about dependent or matched pairs, at that time we work with mu d. But when we are talking in independent samples, at that time we do not work with mu d. Okay, we write it as it is. So null hypothesis is mu1 equal to mu2 and alternate hypothesis is mu1 not equal to mu2 or mu1 more than mu2 or mu1 less than mu2. So let's look into that. So these are the steps. We go over that. What is different in this? Because there are two different samples and they are not dependent to each other, we are gonna run two sample t-test. We are gonna run t-test because we are talking in mean, right? So we're gonna enter our data into L1 and L2 and we are gonna run two sample t-tests. So let me explain all that using an example. Assume that populations are normally distributed. So assuming that populations are normally distributed, so that is gonna verify our requirements. The main requirement is that N1 here is given to be 15, N2 is given to be 15. Sample mean for the first sample is given to be 15.3. Sample mean for the second sample is given to be 14.2. Standard deviation for the first sample is given 3.2. Standard deviation for the second sample is given to be 3.2. Test whether mu1 is not equal to mu2. So the first step would be to write hypothesis. So we need to write null hypothesis, that would be mu1 equal to mu2. Alternate hypothesis, we need to check mu1 is not equal to mu2. Those are our hypotheses. So alpha is given to be 0.05. We need to run two sample t-test. Okay, so let's see that because they are not given dependent, we are assuming they are independent. two sample t-test is in test at number 4. Two sample t-test. Enter that. What are we given with? We in the our question we are given with stats, right? Because data is not given. X bar is given and S standard deviation is given. So we're going to highlight stats. X1 bar, that means the sample mean for the first data set is this, and standard deviation for the first sample is this. N1 is 15. Okay, and X2 bar is sample mean for the second sample. Standard deviation for the second sample is this, and N2 is 15. What are we testing? We are testing not equal to, less than, or more equal to. So not equal to, that is what we are testing here in our null hypothesis. Leave it to not pooled. Okay, we don't have data pooled. So press calculate. So this is what we are getting. So what do we get? The test statistic T naught is 0.898 and p-value is 0.377 for the third digit rounding up. Okay, so let's look in the test statistic method. So we have our t-distribution curve. Because of this, we are saying we are gonna draw two-tailed curve. So we need to draw two critical regions. These are our critical region. We name them either critical region or rejection region. What are these values dividing? This is negative because it's into two tails. We are going to divide alpha into two parts. Alpha is given to be 0.05. That means this is negative t 0.025 and t 0.025. Positive and negative, both values, right? And degrees of freedom is, for degrees of freedom, you need to check both n1 and n2 value. Calculate n1 minus 1 and calculate n2 minus 1. In this case, both are 14. You need to pick smallest of that. So here in your notes, it's written for degrees of freedom, you need to use, for the critical value, use the smaller n1 minus 1 or n2 minus 1 degrees of freedom out of those two numbers, right? So in our problem, degrees of freedom is 14. So we need to look at our Collin formula chart. At 14 and 0.025 would be this number here, 0.025, and degrees of freedom is 14, that's 2.145. So we have this value is negative 2.145 and this is 2.145. Okay, so that is our critical region divider. And our test statistic, let's see where our test statistic is lying. Test statistic is 0.898. So that is going to lie somewhere here, 0.898. That is your test statistic. So we can say test statistic is not in the critical region or the rejection region. So do not reject H naught. That is using classical approach, right? So this is our decision. And we can check p-value also. Actually, p-value, if you see, this is more than, p-value is more than alpha. Alpha is only 0.05. So according to p-value approach, we also say do not reject H naught, right? So what is our conclusion? Our hypotheses were here. We are saying do not reject H naught. That means reject H1, right? So what does that mean? That means do not reject H naught means reject H1. So what will be the conclusion? Conclusion will be there is insufficient evidence to support that mu1 is not equal to mu2. That was our alternate hypothesis. We do not have enough evidence to support that. That is question number 1.